Okay, so here we're going to apply the midpoint formula to find the missing vertex. It's not the only way to solve the problem. I think what's on the left is really, really important. So this labeling convention will help you quite a lot. It's really important to remember. If you come into a situation where you're going to have to draw the diagram and you're just given these points, then it's really useful to know that standard labeling convention of any polygon, so triangle, hexagon, whatever, you start at one vertex, you call that A, and then you go round the points, round in a circle. And you can go clockwise or anti-clockwise, but you should go around in a circle when labeling your points. And if somebody's described a polygon to you, say in an exam question, but haven't drawn it, but they've referenced points A, B, C, D, E, if you need to draw yourself a diagram, then you should make sure you go around in a circle. It doesn't matter which way you go, but if you don't go around in a circle, you might sort of lead yourself down the wrong path in terms of how your geometric reasoning is going to work. So knowing that it's standard practice and knowing that to find the coordinates of a midpoint, so the midpoint formula, you just find halfway between the x coordinates, as in the average, add them up and divide by 2, halfway between the y coordinates, as in the two different y coordinates of the separate points, so the y coordinate of the first point, plus the y coordinate of the second point, divided by 2, and then you do exactly the same with the z's, and that will give you the x, y, and z ordinates of the midpoints between the 2 points in a 3-dimensional space. So we're just going to do this example. Given that 3 of the vertices of a parallelogram, A, B, C, D, are A, B, and C, determine the coordinates of vertex D. So if we just draw this, so there's a parallelogram. And by the way, this isn't the only way to do it. And if I just start with A, B, C, and D, we know the coordinates of A, B, and C, so D's the bit we don't know. So what you could do, you could realize that BA was completely parallel as in a vector. It's exactly the same vector as CD. So we could work out the vector BA, and then we could do that vector from C. We could do that journey, and that would get us to D. So that's a perfectly valid method. I'm going to show you how to do it using midpoints. So what I mean by that is, if I just draw the diagonals for a parallelogram, that's not the best drawing in the world, but basically the diagonals cross at the midpoint. So the midpoint of AC will be exactly the same as the midpoint of BD. So what we're going to do, we're going to work out the midpoint that we can, which is AC, and then once we have that point, we're going to do some algebra to find point D. So midpoint is at, remember I'm using A and C to do this, so we're using the coordinates of A and C. So we're going to average the x's, so that would be 3 plus minus 1 over 2, so 3 minus 1 over 2, that's the x bit. Then we do the same for the y's, so you've got minus 1 and 1, so minus 1 plus 1 over 2, so it's going to be 0. And for the z's, you've got a 2 and a 2, so you've got 2 plus 2 over 2. So that means that the midpoint is at, well, 3 minus 1 is 2, 2 over 2 is 1, minus 1 plus 1 is 0 over 2, which is 0, and 2 plus 2 is 4 over 2 is 2. Of course, the average of 2 and 2 is 2. So now we know where the midpoint is, well, we can apply the same formula between B and D. We know the coordinates of B. We don't know D, but we know that the answer to the midpoint formula will be 1, 0, 2. So what we can say is between B and D, if we call, say, D is at, well, we could call it like x1, y1, z1, or you could just call it x, y, z, but I'll stick with the x1, y1, z1. It's just the x, y, and z coordinates of point D. So the midpoint we know is at 1, 0, 2. We know that point B is at 1, 2, minus 4. So if we think about the x bits, we know that the x coordinate of B plus the x coordinate of D, if we add them together and divide by 2, we must get the x coordinate of the midpoint 1. So x1 plus the x coordinate of B is 1 over 2 must equal the x coordinate of the midpoint. So that must mean x1 equals, well, it's you times by the 2 and you take away 1. So 1 times 2 is 2, take away 1. So it must be 1. Do the same for the y's. So the y coordinate of point D, we said was y1, plus the y coordinate of point B is 2 over 2 equals the y coordinate of the midpoint, 0. So that must mean that y1 equals minus 2. And the same for the z's. z1 plus the z coordinate of point B, which is minus 4. So z1 minus 4 over 2 equals the z coordinate of the midpoint, which is 2. So 2 times 2 is 4. 4 plus 4 is 8. So z1 must equal 8. So the coordinates of vertex D is at 1, minus 2,